everyone, my name is Laura Clark and I'm going to talk to you about the differences and characteristics of volcanoes. So first up we have the cinder cones. These are the most common type of volcano. They form quickly, a few months to years. Lava is ejected from a single vent. They're the smallest volcano, ranging from 300 feet to 1,200 feet. They are mostly monogenic, meaning they're created from a single eruption, and a good identifier of a cinder cone volcano is a crater on top, like the one here, Sunset Crater in Flagstaff, Arizona. You can also find these at both divergent and convergent plate boundaries, and they can be found on other volcanoes. You can find cinder cone volcanoes on shield volcanoes and on composite volcanoes. Their steepness is greater than 20 degrees, and they are mostly mafic. Your composite volcanoes, or also called stratovolcanoes. These are the volcanoes. They're much larger than cinder cone volcanoes. They can reach up to 8,000 feet. And like I said before, you can find a cinder cone volcano actually on a stratovolcano or composite volcano. So that tells you a little bit about their size. They're moderately steep, 10 to 30 degrees, and the reason they have this shape, the way they're built, is lava that erupts over time. They're built from lava flows on top of lava flows, on top of ash and stone, just over and over as it flows down to give it this shape. They form at convergent plate boundaries with the oceanic crust subducting at the continental crust. So if you look at a map of your composite volcanoes, you're going to find most of them on the shorelines because they are at those plate boundaries. And when they erupt with great violence. The pressure builds in the magma chamber as gas, and when it blows, it can blow out the top, the sides, it can blow out one area or several areas simultaneously. So it can be very dangerous. Rock and debris and everything if that summit comes off, so you don't just have lava slowly spewing down, you have lava, you have ash, you have rock, landslides, mudslides, all kinds of chaos going on with these things. They compare it to like if you took a 20-ounce Coca-Cola bottle and shook it up and took the lid off, the way it would explode. That's how these things explode, very violently. And this one, here's a good example here, is Mount St. Helens. And if you go and look at a picture of Mount St. Helens before and after, before its eruption in the 1980s, it was 81. If you look before its eruption and after its eruption, look at the difference in Mount St. Helens. The top of it is missing. It's just gone. Shield volcanoes. So shield volcanoes, these are the largest volcanoes. They're huge. They can be several thousand feet tall. They are always mafic. They are not steep. They're 2 to 10 degrees. They kind of look like just a big, large mound, if you will. They don't really have that, what you think of as a volcano shape. They're the most active volcanoes. They don't explode like your composite volcanoes. The lava flows easily. It flows slower. They compare it to like if you take a full cup of water, and you poured water in it, the way it would just spill over the top. That's kind of what the shield volcanoes do. They still have these pretty little bright explosions like this one here in the picture, but the lava it moves slowly. So they are not as explosive as they don't explode. They still explode, but not in an eruptive manner. They may be constantly exploding for years, but it's not going to be as violent as the explosion like you would get from a composite volcano. So you'll find shield volcanoes. A lot of these, Hawaii is made up of shield volcanoes. The island, the main island, over half of it is volcanoes. Lava domes. This really wasn't considered a volcano in our unit, but I wanted to put it in here because I thought it was notable just to talk about the lava domes just for a second. Lava domes are found on stratovolcanoes or composite volcanoes. They have a dome shape, that's why they're called lava domes. And actually inside this bulge is lava, and it can change shape. It can get bigger, it can contract with the magma that's in there. And just like a standing alone volcano, this lava dome can erupt on the composite volcano. So this lava dome in particular is inside a crater here at Mount St. Helens, and it can erupt on its own. You can see smoke coming out of it. So they evolve unpredictably, don't really know how they're going to grow or shrink. They can be several hundred feet, grow for months, years, centuries, and they're composed of unstable rock debris on the sides. But these also contain the lava that comes from these contain the rhyolitic silica-rich lava. Large igneous provinces. Again, this really doesn't look like what you would call a volcano, but it does have to do with volcanoism. So large igneous provinces are huge, and they're mafic. They're created with thick magma, and they're thought to have they're associated with mass extinction and climate change. So the igneous provinces are a mix of intrusive and extrusive igneous rock, and they almost just look like the magma just came up out of the ground and then cooled and left all these strange looking formations. But again, they don't look like they don't look like a composite volcano or a shield volcano or a cinder cone or a lava dome. So just from the shapes that they make, they're pretty identifiable that way. Seafloor volcanoism. So this seafloor volcanoism, this is going to occur in the ocean, usually near mid-ocean ridges. There's estimated to be over 1 million seafloor volcanoes. They're hard to study, of course, because they're deep down in the ocean. They can be in the deepest part of the oceans. They can also be in shallow part of the oceans, but they're usually in deep part of the oceans. And they're associated with mantle plumes and spreading ridges. A lot of them are now extinct, but this explains why the salt on the floor of the ocean, where that came from. It's from seafloor volcanoes. And kimberlite. Again, this one doesn't really look like your typical volcano, but it is pretty cool. These are upper mantle source. So the kimberlite pushes up through the asthenosphere and then the lithosphere and the crust quickly, and it's almost like it drills through it. It does it quickly and creates it leaves behind some pretty cool things like diamonds and other gemstones, probably due to the way that, because of the carbon and the way that it comes through so quickly. So a lot of your diamond mines are actually kimberlite. Those are where most of the diamonds come from, and the remnants of these can be spread across hundreds of meters. So it's like a pipe-like form, so they come up like a dike through the earth. But they're pretty cool looking, and there's diamonds and other gemstones in there, so that's pretty neat. Okay, so that is the end of my differences and characteristics of volcanoes. I'm going to leave y'all with this slide here, and you can look at it and see if you can identify these 4 tops of volcanoes. I'm not going to tell you the answer.